Hello, Accelerated Math 7-8 students, and welcome to our fourth video. Table of contents, our fourth video is called Addition and Subtraction of Rational Numbers, and we find that in my comp book on page 14. So I'm going to turn there now, page 14. And again, the name of it is Addition and Subtraction of Rational Numbers. So these set of notes are kind of fun because you're just practicing what we've been working on with integers and other rational numbers with adding and subtracting. I know that there have been a lot of new clues and hints and models and that kind of stuff to help you. And one of the biggest things that I can tell you with this specific information is the more practice, the better. Okay? And so that's our goal. Today we are going to practice adding and subtracting rational numbers. The question that I want you to be thinking about while we're working with this lesson is, what is a property that you could use to help make adding or subtracting rational numbers easier? Okay? And that's basically what we're going to talk about, is I'm going to give you a couple of tools to help you figure out how to make this process of working with adding and subtracting rational numbers easier so that you don't get confused, if you're getting confused. So the first thing that I want you to do is I want you to look at this, and we talked a little bit about this in our last few lessons, proving mathematics so that your brain believes that how the strategies work actually do work. So my first question is, are these the same? And then you're supposed to prove it. And I left you some space in your notebook because I want to see your work. Just a quick reminder, in the ways of proving, you can use the chip model, you can use the number line model, you can use the, if it's a subtraction problem, you can add the opposite, whatever you feel comfortable with proving it. Now, the one thing that I would like you to remember and recommend is if we're trying to prove they're the same, then I would like you to stick to the operation that it's doing. So in this problem, we're actually subtracting. So try to be true to subtracting. This one is adding, so we're going to try to be true to adding. Okay, I would like you to figure that out. All right. Now, having the fact that you have figured that out, we're going to try something else. Okay, so I have, this section is called Let's Try Something Else. And I basically took your same expression from up there and I turned it into an equation. So I have 4 plus a negative 5.5 equals a negative 1 1/2. Okay? Now, the thing that I need you to focus on for a second is 4 is considered a rational number. 5.5 is also considered a rational number. Oh, it's not working. I was trying to make this a little bigger so you guys could see it better, but it doesn't look like we're getting anywhere. So, okay. So we have 4 is a rational number, negative 5.5 is a rational number, and then we have the sum. And the sum is a rational number too, but I didn't want to write rational number because I want you to recognize that this is the sum of these two right here. So what I want you to look at, however, when you're thinking about this sum is, what is the opposite of this sum right here? What would you call the opposite of this sum right here? Negative 1.5, its opposite would be positive 1.5. Very good. So we have a positive 1.5 is the opposite of the sum. Now you're going, oh my gosh, Mrs. Nelson, why are you doing this? Well, I'm doing this because now I want you to check out this one right here. Notice what I did, all right? And I'm going to cover this up because I don't want you to look at it just yet. But I want you to focus. What do you see that is different from last time? So this one up here, 4, and it's a rational number. This one is now what? It's still a rational number, but what is different about it? 4, negative 4. Do you see it? 4, negative 4. 4, negative 4. Okay? Hopefully you have an idea of what's different about it. This little one right here is also still a rational number. Okay? Again, I want you to notice what's different. Negative 5.5, 5.5. Negative 5.5, 5.5. Notice the sign stayed the same. Okay, so no changing of the operation. Okay, and then we have a sum right here. Oh, wait a minute. This is a sum. This is a sum. What do you notice that is different? Negative 1.5, 1.5. Negative 1.5, 1.5. Okay? So the question that I have right here that I want you to look at is, remember how I asked you to determine the opposite of the sum, and you told me 1.5. Look at this one, 1.5. So my question is, are these, talking about this sum and this opposite of the sum, are they the same? You should be saying yes. Okay? Now, you're sitting there going, why is she doing this? Again, it's another strategy to help you, but here's the rule. The rule is, what we can learn from this is, so the opposite of a sum is the sum of its opposites. Now I know I can just hear Jackson in the background going, Mrs. Nelson, we already talked about the opposite of the opposite is the opposite. Remember that? And I think you guys started giggling a couple days ago because I remember hearing someone between your classes saying, remember, the opposite of the opposite is the opposite. Well, this is kind of like that, except let's read it again. The opposite of the sum. So this was the original sum. The opposite of that sum is 1.5. The opposite of the sum is the sum of its opposites. Oh, so this went from being 4 to negative 4, still adding. This went from being a negative 5.5 to a positive 5.5, and we get the opposite of a sum is the sum of its opposites. So we get the opposite, and it's the exact same answer. Okay? Now, some of you are going, I am so confused why she's doing this. Sometimes when you get a problem that, let's say, it has a ton of add-ins. Add-ins are the numbers that are being added. So let's say we have negative 4 plus 8 plus a negative 2 plus 5 plus a negative 3 plus a negative 1. Okay? Now, some of you are going, okay, I'll just string it along, I'll do the chip model, and it'll be good. Well, sometimes figuring out the answer can be easier if you remember that the opposite of a sum is the sum of its opposites. Well, let's prove that. Okay, so we're going to say this is 4 because that's the opposite. We're now going to say this is negative 8 because that's the opposite. This is going to be, I don't need brackets because it's going to be a positive 2 because that's the opposite, and a negative 5 because that's the opposite, and a 3 because that's the opposite, and a 1 because that's the opposite. So we could go really fast, right? And we could say, okay, 1 is a positive, 3 is a positive, 2 is a positive, and 4 is a positive. Okay, that's easy. So 4, 5, 6, 7, 8, 9, 10. So now I have 10 plus a negative 8 plus a negative 5 equals, right? Well, I also know the rules that if you add a negative and a negative, you get a negative, and then you add them together, so that's 13. And then I'm bringing down the plus 10, and then that's a lot easier problem, because then I can just say, okay, well, if I add 10, starting at 0, go up to 10, right? So here's 10. And then I'm supposed to add 13 negatives. So that means I have to go all the way back there as 10, 11, 12, 13, and I end up with an answer of negative 3. So this is a negative 3. Now, I'm wondering if this answer, oh, you can't see it, sorry. I'm wondering if this answer is actually this. Because remember we said the opposite of a sum is the sum of its opposites. Well, these are the opposites. So let's try this one. 8 and 5 are 13. So we have 13 over here. And then we have a negative and a negative and a negative and a negative. If they're all negative, you know your answer is going to be negative, and then you add them. So 4, 5, 6, 7, 8, 9, 10. So I have negative 10 plus 13, and bum-ba-da-bum. Are they opposites of each other? Yes. Did we prove it to be correct? Yes. Now, boys and girls, again, I don't know if this one necessarily makes it easier, but it's definitely a way for you to check. It's also an excellent way to give you some extra practice, because remember, I've been talking about that practice with these kinds of number sets makes you perfect. It just makes you feel 100% better about doing this. So that was supposed to be a little bit of a fun aha moment. You can take it for what it's worth. Moving on, again, title up at the top. I've been noticing when I've been checking that a lot of you have forgotten that, so make sure you get your title up at the top. Using the opposite of a sum is the opposite of its opposites can make adding and subtracting rational numbers easier. It depends. It really do. It's a personal decision. All right, here's another way that I want you to be thinking about. So we have 7 plus a negative 9, or negative 9 plus 7. Now this is truly just a specific preference. Sometimes when I see problems written like this, I have to really train my brain to figure out what's going on. However, when I see it like this, for some reason in my mind it's a lot easier. And I don't know if it's because, okay, I'm starting in the negatives and I'm adding positives, so I'm just going to go right, so I know I'm headed to the right. I don't know. I can't explain it. But for some reason, to me, this is easier than working with this one. So which problem looks easier to you? To Mrs. Nelson, this is the one that looks easier. So as long as you are adding, this is the most important part. You have to be adding. If you're subtracting, it will not work. As long as you are adding, you can use the commutative property to make the problem easier because changing the order of the numbers does not change the answer. Okay, so let's try it. For this one, I use the chip method. So I have 1, 2, 3, 4, 5, 6, 7 positive chips. 1, 2, 3, 4, 5, 6, 7, 8, 9 negative chips. I made my 0 pair, 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 and then I'm left with these two little negative guys sitting right here. Okay? The number line on this one, remember how I told you for some reason to my brain it's easier? So here's my number line, here's 0, I count down to 9, and then I have to count up to 7, and boom, I'm done. Negative 2. Do you notice that the answers are exactly the same? So does the order, as long as you're adding, does the order matter which one you do first? The answer is no. And that's a very big hint for our question of the day or our question of the lesson. All right, we are almost finished, kiddos. I am leaving you with some practice, okay? And what I would like you to practice is I would like you to practice the opposite of the sum, which was that funny little thing we did over under try something else. So these 3 problems, I would like you to use the opposite of the sum to figure them out and see if you can do it, because it is kind of a challenge, definitely. So check it out, try it. We will check them in the morning. Those will be the problems that are left up on the board, along with how you proved this, that they were the same, using 2 examples to show me, show your work, show your work, show your work. I know we've been talking about that a lot. And then the other thing I'm looking for is...
Good afternoon, Sonoma.
I'm going to go. You know the question of the day. I'll talk to you later.
8th grade
Bye.
volleyball.